as h goes to 0. So one thing was to square the x plus h. Now, I might do that over on the side here. X plus h squared is the same as x plus h times x plus h. And so when I square that, I get x squared plus xh plus a second xh plus h squared. So that multiplication looks like x squared plus 2xh plus h squared. So x plus h is x squared plus 2xh plus h squared. Okay? So we've expanded x plus h quantity squared. We can now distribute the negative 2. So we've got minus 2x minus 2h. All right, now we've got our plus 4, and that's the end of our first portion. And then that negative in the middle, the minus between our f of x plus h and our f of x, we can distribute that to the second set of parentheses. So we have minus x squared plus 2x minus 4. All of that is over h. All right, so we've taken care of all of our expanding in one fell swoop. Any questions about that? Okay, so hopefully things will start to cancel. Is there anything that cancels?
X squared.
Yeah, the x squareds cancel. Bang. Okay, the 4's cancel.
The 2x.
Yep, we've got a minus 2x and a positive 2x. Anything else? Looks like about it. All right, so we've got the limit as h goes to 0 of 2xh plus h squared minus 2h all over h. All right, now at this point, I take a breather because I've just done a whole bunch of calculating, and I step back and I say, okay, am I in a good position? When I look at my numerator, am I able to factor an h out of every single term? And the answer is yes, so we're happy about that. Well, let's go ahead and do that. So we've got the limit as h goes to 0 of h times 2x plus h minus 2 over h. All right, so we can knock these h's out, and it leaves us with the limit as h goes to 0 of 2x plus h minus 2. And now that I've removed the denominator, it's of no consequence to us now, I can take this all the way to the limit and allow h to go all the way to 0. And so what that leaves me with is I end up with 2x plus 0 minus 2. And so my final answer is that f prime of x is equal to 2x minus 2.
And we don't need to factor that any further.
No, I mean, if you want to, you can pull out the 2, but it's not worth the time. Okay, so I want you to take a look at what we started with. We started with this original function. Oh, that's the wrong function. Don't look at that one. Cross that one off. Try looking at this one instead. So this was our original function. Okay, f of x is equal to x squared minus 2x plus 4. And that function over there, when we graph this function, the input is an x value, and the output is the height of this function. It's a y value. Now, when I look at this formula over here, actually, it looks like I have another function over here, because it looks like I have a function whose name is f prime. We're inputting x's, and the output is some sort of function that depends on x. And so this is a function where the input is an x value, and the output is the slope of our original function, f. All right, right, so some things that we might be able to do at this point. We actually wanted to calculate the slope of the tangent line at all of these different x values. I might not do all of those x values right now, but let's take a look at a couple of them. Let's look at when x is equal to 0, when x is equal to 1, and when x is equal to 25. So when I calculate f prime of 0, yeah, when I plug in 0 for f prime, or when I plug in 0 for x into my f prime function, I've got 2 times 0 minus 2, which gives us negative 2. Now, what that number is telling us, this is our slope, and this tells us that our original function f must be going downhill, okay, because our slope is negative. So, the original function f is moving downhill when x is equal to 0. So let's take a look at x is equal to 1. So we'll look at f prime of 1. And so everywhere that I see an x in my f prime function, I'm going to plug in 1. So I've got 2 times 1 minus 2. Gives me an output of 0. And so what this is telling me is that my original function f must be flat when x is equal to 0. Yes, thank you. When x. So glad you're here. Thanks, Mom. Okay, so f must be flat when x is equal to 1 because our derivative is equal to 0. All right, so let's take a look at x is equal to 25. So if we plug in 25 into our derivative function, we have 2 times 25 minus 2. So that's 50 minus 2, which is 48. So this is a positive number, which tells us that our function is moving uphill as we read left to right. And not only is our function moving uphill, but this is a pretty stinking large number. Okay? So this is a large slope. It tells us that not only is our function moving uphill, but it's moving uphill very steeply. So f is moving uphill, and f is very steep. The uphill comes from 48 being positive. The very steep comes because 48 is a large number. Okay, so if you have your calculator, I'd like you to graph our original function x squared minus 2x plus 4. When you get a picture, check